Hi all, I'm Kyle, and welcome to our series of videos on BioRT-HBV model. In the past few videos, I have been talking about creating input files required for running BioRT-HBV model. So in this video, I'm going to talk about two particular input files, and they are soil and precipchem files. In this file, you can find all the BioRT-HBV input files that are required with the files that I'm discussing in this video highlighted. If you look at the BioRT-HBV structure, you can find that there are mainly two zones, shallow zone and deep zone in the subsurface. Shallow zone or upper zone in the input file denotes whether solid material that contains large amount of organic matter, whereas deep zone or lower zone denotes less weathered, deeper bedrock material. We need to specify some characteristics about these zones in our soil file, and these characteristics are porosity, passive water storage, and depth. To be exact, the parameters are porosity upper zone, porosity lower zone, WS passive upper zone, WS passive lower zone, depth upper zone, and depth lower zone. Porosity refers to the proportion of pore space in the subsurface. The porosity defined here is different from the measurements taken outside, as they are only point measurements. However, porosity defined here refers to effective porosity at catchment scale and therefore is more of a calibration parameter. Before talking about passive water storage, I want to talk about water storage in subsurface. If you look at the water stored in the subsurface, there are two types of water, dynamic water and passive water. Dynamic water is a water storage that is involved in stream flow generation and is the one simulated by hydrological models like HBV Light. However, there is some other water in the subsurface known as passive water, which does not participate in stream flow generation processes, but still affects reaction and transport processes. In reactive transport models, we need to quantify this passive water storage too. And that's why we have this passive water storage in upper zone and lower zone in our soil file. Finally, we also need to specify the depth of these zones in our soil file. So next, let's look at an example soil file for the Sleepers River catchment that we have been looking at in our series of video. So here you can look at porosity in upper zone and lower zone first given, and they don't have any units. However, passive water storage and depth are have the units of in soil file. Moving on, let's talk about precipchem file now. So not all sites have precipitation chemistry. However, few sites like the ones near the National Atmospheric Deposition Network do have precipitation chemistry data. And if your site is one of them and you want to use time varying precipitation chemistry as a driver, then you can use precipchem file. To do so, first you need to change the settings in chem file. You need to specify precipchem parameter as 1 in chem file. Then you also should provide the precipchem file. In precipchem file, you should have the time series showing the concentration of all primary species in precipitation, and make sure that the time interval used is same as the one used in hydrology files. So this is an example precipchem file created for Sleepers River. And you can see that I have shown all the concentrations of primary species. And also, before ending the video, I also want to show the input files in particular. So this is exactly what we saw in the PowerPoint presentation too. And this is the precipchem file. Finally, this is the chem file, and you can see that we should set this precipchem as 1 here, so that the precipitation so that the precipitation chemistry defined in precipchem text will be used. So in this video, we looked at soil and precipchem file required for running BioRT-HBV, and see you people in another video. Thank you.